Hi, welcome to this MySportsAI video. This video is going to be a snapshot of the system. It's going to give you an overview of how the system works, and in many ways it's going to be a compression of the areas I covered in the first 10 videos which showed the development of the system. Hopefully it'll help you get a feel for how the system works, how you can use the software before you actually download it and download it onto your PC or laptop and actually get playing with it. Okay, let's get started. First of all, we've got the main screen up here. One point I just want to make is that at the moment, when you've downloaded the software and you're running it, you'll also have a DOS window up as well, sort of sat behind the main screen. That's not going to be a permanent feature. It's there at the moment because it's useful as a sort of reporting mechanism. If there are any glitches in the software and you need to report any problems, you'll be able to see what the error messages are in that DOS screen, and you'll be able to give me a better sense or better feedback on what your problem was that you encountered. But in future versions, I'll probably remove that DOS window because some of the beta testers felt that it was a bit distracting, even though you can collapse it to the bottom of the screen. I'll probably replace it with some sort of spinning icon which shows that the system is doing something, because at the moment the other function of that DOS window is it does report when it's actually carrying out some sort of function like training a model or doing hyperparameter tuning. So it's a way of you checking. It's a window which you can check just to make sure that the system is doing something. So it's there at the moment, but it's probably not going to be a permanent feature. But it's not a big hindrance. Okay, let's get started. The first thing I need to do is probably open a file. There are two things I can do at the moment. Looking at the non-grayed out buttons, I can open a file, which I'm going to do. I'm going to open up flat handicaps from 2011 to 2013. The other thing I could have done on that screen is load a model. Now that would allow me to load a model that I'd previously created and saved. Well, if you're using it for the first time, then of course you won't have a previous model created and saved, so you won't be clicking on the load model. But further down the line, you may want to load up a model that you've previously created and run it on some data. Okay, so I've opened up a file. I haven't yet created anything, but what I'll do first is just go through various parts of the screen. Up here in the top left, we've got an area that reports on the particular features that are available, or input parameters. I may sometimes refer to them as input fields, input parameters, or in machine learning parley, it's often called features. So this will report on the features. If I go and put the cursor over a particular feature like raised class, you'll see that it's now at the top left there reporting on the raised class feature. It's telling me there are 7 instances, which means there are 7 different raised classes within the file. That's not surprising because horse racing class goes from 1 to 7. It says there are 111,726. That's exactly how many rows of data there are in the file. And there's a raised class field on every row, so there's 111,726. It says there are no missing fields, no missing data for this particular field, raised class. And then it reports on what the mean is, the max, and the min values. And you can get that information on any of the data items or the input features. You'll notice down in the bottom right here that you get a distribution plot as well, which gives you a visual clue as to how the data for that particular feature is distributed. Okay, up here we've got a snapshot of the first few rows in the data. So if you just want to take a little look at what the fields consist of, you can scroll across and see what's in there. And then finally up here you've got a window box which describes the file, gives you the file name, how many rows and columns there are, and it will display one or two other things in there later on when we get actually down to carrying out some of the functions within the system, but we'll get to that later. Okay, also we've got down here some buttons. This is a button which allows us to select the algorithm we're going to use to create our model. And we've got a selection of algorithms there. I'm not going to go into them in this video, what they all do, but we can probably cover that later in some articles. So I'm going to use gradient boosting machines. And then there are these parameters we need to set here. We need to tell the system what the event ID is. If it's going to create ratings and rank them within a race and report on the profit and loss on backing top rated, second rated and so on, which it will do, it needs to know which field in the data identifies an event. In this case, it identifies a race, and that field is the race ID, which it picks up there and sets as a default. If you were using data that had a different name, then you could select it here and change it, but obviously in this case race ID is the correct event ID. Similarly, you have to define a field that tells the system whether a horse has won or lost. In this case it's the field called FinPos, and again, if you needed to, you could change this field. I'm going to leave it as FinPos. And then finally you've got the definition of what the price is, the price field. It'll need that in order to calculate profit and losses. So you need to specify what the price field is, and by default it's assuming you are using BFSP in this file, which is correct. Again, you could change it if the price field was called something different. And then down in the bottom here we've got where we can select the fields we're going to use in our model. We can click all, which would select all of them. Not that we would create a model with all of the fields selected. We can clear it, and invert would simply select fields inverted. So it would select every field but the two I've just clicked. Okay, let's create a small simple model just to describe and display the functionality of the software. I'm going to go with the draw and days since last ran, and the pace figure. Now there are explanations. You'll notice that if you put the cursor or put the cursor on any of these fields, up there in the top it will display the description of the field as well. So for pace fig, it's saying it's the run style from the last race, where a value of 0 means it was held up to a maximum of 5.6, which means the horse made all the running. Okay, so we've got those three fields selected. We also just need to make sure that the predict field is selected for FinPos there. We're trying to predict FinPos. We're trying to predict whether a horse has won or lost when we're creating our model. And now these functions here, one hot, scale data and slice data, I'll come back to later. At the moment I'm just going to leave those to last and get on with creating a model. Okay, I've selected my input features. I've selected the feature I'm trying to predict. I've set these up here, they're all set correctly. I can now go up and create a model. Okay, I've got a second window up now. It'll just display the features I've selected, so I can double check, make sure I haven't made any mistakes. And the other thing I can do here is I can, first of all, if I wish, I can do a correlation plot. Now this shows me the correlation between the fields I've selected and the target feature FinPos. So we can see that the draw is negatively correlated, minus 0.05, with FinPos. You just read across rows and columns to see how one feature correlates with another. So in this instance, draw going across over to the last column is negatively correlated with FinPOS. What that means when I say negatively correlated is it means as the draw goes up, the likelihood of a horse winning goes down. And the greater this value, the more correlated the feature is with FinPOS. Don't make the mistake of thinking that a negative correlation, as opposed to say down here with pace figure, which is a positive correlation, don't make the mistake of thinking this is bad and this is good. They're both correlated, and in fact this is more correlated than that one, more correlated than pace figure. The draw is more correlated than pace figure because it's got a value of 5, even though it's a negative value, whereas this is correlated with a value of 3. Now it doesn't mean that the draw, if something is more correlated, doesn't necessarily mean it's going to be more profit generating, because generating profit and generating winners are not necessarily the same thing, as I'm sure you're aware. But this shows the relationship between the features and the target feature. Okay, I'll mention hyperparameters later on, but the next thing is these three options here. This is how we're going to actually train and test the data. The top option is train test split. What that means is very simple. It will split the data into 80% and 20% splits. The first 80% will be the train split, and the last 20% will be the test split. So what it will do is it will train the model on the first 80% of the data, and then it will apply the model to the final 20% of the data, the test split, and see how it performs, and that performance will get reported here. So if I run that now, we'll do a train test split, 80-20 split, and we'll see how this performs. So here we get the results. It tells us that there were 2,288 top ranked bets, almost 15% won, they made a profit. The maximum drawdown is the biggest loss you would have experienced on your bank during this period. That's return on investment. The variable profit loss is how much you would have made or lost betting to win a pound, whereas this is a flat stake over here. The variable return on investment, and this is a value profit and loss. This is where the profit or the bets are calculated based on the probabilities that it produces for the ratings. Essentially what this means is if the probability is greater than the Betfair implied probability, then it's a bet. And if it isn't, then it's not a bet, which is why you've got fewer value bets here than you have over here. This is a description of backing every horse, whereas this is a description of what happens if you only back horses where the probability according to the model is greater than the probability according to the Betfair SP. It's actually a little bit more juice in it than that. What it will do is it'll take the price into account, and also with the price it will not just simply say is it better than Betfair SP, it'll require a little bit extra on top. So for example, if the price was 50 on Betfair, 50.0, it will roughly require that the probability of the model is twice that of Betfair SP. It's actually the probability has to be twice the probability that's calculated on Betfair SP. Whereas if the Betfair SP was even money, then it will log a bet if it's just slightly over the probability of Betfair SP. So I've probably not explained that very well. I'll probably put it in an article. It's made much more clearer. This is the number of value bets, and this is the return on investment on value bets for top ranked horses. Okay, that's the train test bit. Now the other option is k-fold cross validation. This is where the data is split into equal folds, and the model will be trained on, well, I'm going to change this to 5 just to make it a little quicker. It's going to fold the data into 5 equal folds, and it will train on 4 of the folds and then test it on the 5th. Then it will rotate those and train on another 4 folds and test on a different fifth fold, and so on. It'll do that 5 times. And you'll notice that when we see the number of bets here, it'll be much higher because we're effectively getting much more mileage out of the data by creating these folds and train testing on each of the 4 folds and the 5th fold, and then rotating them around. So if I run that, it'll take slightly longer to run. Not too long, I hope, but it does take a little bit longer because it's effectively doing 5 times the work that it was with the train test split. Should be, here we go. Now, as you can see, it's created a lot more bets because it's rotating through the data, and the reporting is pretty much the same here. One thing I didn't mention was a couple of items down here. This shows you the feature importance. So it actually shows you which features played the most prominent role in the model, and which feature was most important. So in this case, the day since last run was, and then the draw followed by the pace figure. And here you've got a Bria skill score, which is a machine learning metric, and essentially if this particular value is greater than 0, it means that the model is demonstrated some skill in predicting outcomes, and if it's less than 0, it isn't. I've got an article on that which I'll refer people to, and you can have a read, and it explains more clearly and more fully what a Bria skill score is. Okay, finally we've got this option here, which is a supply test file. Now, you wouldn't usually use this until you get into the end of your development. It's customary to keep a holdout set of data so that when you've done creating your model and perhaps even hyperparameter tuning it, you've got another set of data that you can finally test it on and get a more out of sample definitive look at whether or not the model's got any worth or not, whether or not how it would perform on totally unseen data. So that's what the supply test file option is. I'm going to run that just to show you. You click run model again, and then you select a test file. You'll get these files. This is year 2014 handicaps. You get these files supplied with the software data 11 to 13 and years 14 as well. And here we get the results coming through. That was on the 2014 data. So it fitted the model on 2011 to 2013, and then it tested it on 2014. So that was some fresh data it tested it on. Okay. Let's go back to the first screen and let's cover some of these features down here, these functionality down here. Let's imagine that I now want to add another feature. I want to add going. Now the problem with adding going is there's no option to add it to the input fields. That's because going is a object. It's not a numeric data item. It's basically got characters in there like FM for firm, GS for good to soft, and so on. Now you can't run machine learning algorithms on non-numeric data, but it's not a problem because what we can do is one hot encode it. And if I click one hot here and then click one hot encode from the button up here, you'll see that it's removed going from the list and replaced it down here with a single variable for each one of the goings that occurs in the data. Now these are each one of these is a 0 or a 1 in value. So if the going was good for a particular row of data, it'll have a 1 in it, and if it wasn't good, it'll have a 0 in it. And what we've effectively done now is created numeric values for all these goings, and we can now actually go ahead and use them in our model. So if I click on these, I can run them in my model. I'll do the train test split, it's the quickest. And we're now running the model on a train test split with draw, days, pace figure, and either a 0 or 1 for each one of these goings here. And we get some fresh results. So that's a one-hot encoding. A way of including non-numeric data into our data models by converting them into numeric form. Okay, next I'm going to look at slicing data. So what if I feel that perhaps this particular model might work best with certain tracks and certain class of race, maybe lower class races. So if I select track for slice data and I select race class, and then I click on slice data, I've now got the option to, let's move that up a bit. I've now got the option to prune down the data to just certain race classes. I can select here greater than, and if I put 4 in there, I'm now effectively selecting only race classes, races of class greater than 4, so 5, 6 and 7. And let's say I want to just do all weather racing. Then I can select all the all weather tracks. Kempton. I think during this period there wasn't a Chelmsford, was there? I think that's the all weather tracks. If I miss one, doesn't matter. But I think they're all the all weather tracks. And now if I click slice data, it'll prune the data down to only those that qualify as greater than class 4 and on those particular tracks. It'll actually show you up here the selection criteria that you just applied, and you'll notice that the number of rows is greatly reduced to 33,000, whereas before I think it was about 111,000. So we're now working on a subset of the data, and if we want, we can go ahead and run our model, which is still set up there. We can run our model on this subset of the original data. Okay, one final functionality here is scaling data. Some algorithms tend to work better with data that's scaled between 0 and 1. Neural networks is probably one example, and this allows you to scale data down to between values of 0 and 1. Let's do it on one of the data items. Let's look at what have we got here. Let's look at well, let's do it on draw. Sorry, wrong one. It doesn't matter how relevant it is. It's just a demonstration of the functionality. I'll cover a little bit more about these, or the whys and wherefores of doing some of these things, perhaps in an article. But if I click on scale data for draw, and then click on scaler, you've got 3 different types of scaler here, which you can select from. I'll explain these in an article, but the default is min-max scaler. The selection that I made here, draw, now if I click scale it, it'll scale the draw down to values between 0 and 1. So if I have the cursor on draw here, you'll see, looking up here, that the maximum value is 1 and the minimum value is 0. So draw 1 will be 0, and the highest value draw, which was probably a 36 runner field, has a value of 1. all the other drawers have been scaled in between those values. Okay, finally, we've created a model. We may want to save it for later. We can click on Save Model. We just need to name it. I'll put it as test pace as a name. Click Save. The model has been saved. We can come back later and we can load the model up. There it is. It'll load it up and show you all the particular parameters that you set, just as they were when you actually created it. And then finally, we've got this function here, model dex. This will allow you to load, once you've loaded up a model, if you click on this, you'll be able to model today's declarations. Now there is a file, there are no runners of course at the moment, but there is a file there, an old file, and it's telling me that 80 runners, 80 declarations have been loaded up. I'm not actually going to run that, because at the moment the full functionality of modeling the dex has not been implemented. It's there, the functionality works, but I haven't created any dex files that have all of these features included. So it's only going to run with 4 or 5 of these features at the moment. But by the time racing resumes, any of these features that you select here will be available in the dex file, and when you click on model dex, it'll apply your model to today's declarations and give you your ratings for today. There are a few other things I've probably missed out. I think the other thing I missed out was that over here, once you've created your model, if I run that again, once you've created your model, you can save the results here, and it will actually save all of the results that the model produced. That's not these results here, the detailed results, the line by line results. It'll show you the probabilities, the Betfair SB, the value price, and so on. It's in a CSV file which you can then take a look at and work with. Okay, that's probably enough for today. Hope you enjoyed the video, got something out of it, and gets you started once you've downloaded the software. Give me a thumbs up if you found the video useful, and I'll look forward to your feedback on the email forum that we've set up. There's already been a lot of good discussion on there about how to use the software. Thank you.